Okay, section 1.8 video, part 1. What I want to do before I begin this section is I want to review back over something that you probably will remember. But anyway, so what I want you to do, let me make sure that you can see the whole part of both of these problems. Yes. Okay, pause the video now and copy both of these problems. Okay, I'm assuming you copied that. Now, let's do this one more time. Pause the video now and copy this one. Okay. Now, let me go over this. This is not what we're going to be doing in this section, but we're going to use it. If this were an equal sign right here, this would be a linear equation, if this was an equal, because x is to the first power. Now, it's not an equal sign here. There's one of your inequality symbols. Remember, there's 4 types of inequality symbols. There's the greater than or equal to, just the greater than, the less than or equal to, and the less than. This one is the greater than or equal to. So this is a linear inequality. Now remember, when you solve a linear inequality, you basically use the same process that you use with a linear equation. You get your x's on one side, numbers on the other. So if I solve this like I do a linear equation, I would have to first subtract 12 from both sides. When I do, I get 2x greater than or equal to negative 6. Divide both sides by 2 to get x is greater than or equal to negative 3. Now remember, whenever we solve an inequality, we oftentimes do something a little different to it that we don't do to equations, and it's this. We represent the solution graphically on a number line. So if I wanted to graphically represent all of the numbers greater than or equal to negative 3, where are all of the numbers greater than or equal to negative 3? All of the numbers to the right of negative 3. So this graph would start at negative 3 and go to the right. A bracket because of the equal to. Remember, if this equal to had not been there, there'd just be a parentheses. Something else that we do that you've seen this course is interval notation. A way to write that intervally is everything from negative 3 on to infinity. Remember, we never put a bracket on the infinity. All right, now let's look at the second one that you copied, because it's pretty similar, but one little difference. All right, if I'm going to solve this, I'll start out and subtract 3 from both sides to get negative 2x greater than negative 10. To get rid of the negative 2 in front of the x, you have to divide. But remember, with inequalities, if you divide by a negative number, you have to invert or flip the inequality symbol. And so in this one, you will notice that we did that very thing. We inverted the symbol because we divided by a negative. Now, we didn't do that in the first one because we didn't divide by a negative. Okay, now how do I represent all of the numbers less than 5? All of the numbers less than 5 would be all of the numbers starting at 5 to the left. A parentheses on the 5 because there's no equal to. Because this graph goes to the left forever, we call that negative infinity. So it's from negative infinity up to 5. And the negative infinity always has to go on the left side of the comma. Always a parentheses with the negative infinity. Now, we've talked about both of these a little bit during the semester. Now, one that you probably haven't seen in a while, and you may not remember it at all, is one that looks like this. This is what we call a compound inequality. You may not remember that name, but here's why we call it a compound inequality. A compound inequality, just like a compound word is a word made up of 2 words, like rainbow. One word made up of 2. A compound inequality is an inequality statement that has 2 inequality symbols. Now, the goal on a compound inequality is not to get the x on the left. It's not to get the x on the right. It's to get the x by itself in the middle. So if you look at the middle here, is the x by itself? Well, no, it's not. So what I've got to do first is get rid of the subtracting 3. How do you get rid of the subtracting 3? By adding 3 to both sides. Now, I know a lot of you use the language, move the 3 over. And to be honest, I've probably been guilty of that myself. But you're really adding 3 to both sides. So, here's the difference. You don't just have 2 sides now, you have a third side. So to get rid of this subtracting 3, you add 3 to the middle, to the right, and to the left. That's one of the reasons I don't particularly like using the words move it across. Because if you use the words move it across, now you've got to say move it across to this side and that side. So it's add 3, add 3, add 3. Now when you do, the 3's add out to 0. Over here, this will become 4. Over here, this will become negative 2. Now, is the inequality problem solved yet? No. And the reason it's not is because the objective is to get the x by itself in the middle. All right, this is 2 times x, so to get rid of that multiplying 2, you divide by 2. But whatever you do to the middle, you have to do to the right, and you have to do to the left. So divide the middle, left, and right by 2. Now, negative 2 divided by 2 is negative 1. Here the 2's cancel and leaves just x. And here 4 divided by 2 is 2. All right. So that's a little different because it's a compound inequality. The graph is also a little different. When you graph a compound inequality, the graph is always between your two numbers. So the graph doesn't go forever in one direction or the other. So this just simply means x represents all of the numbers between negative 1 and positive 2. So the graph here got 0, 1, 2, and negative 1, everything between negative 1 and positive 2. We'll put a bracket on the negative 1 because of the equal to. There is no equal to under the 2, so there'll only be a parentheses. So this graph does not go forever in one direction. It has a starting and a stopping point. Then the interval notation, there's no infinity business here. The interval notation is graphically or describing the graph numerically from left to right. So this graph starts at negative 1, ends at 2. Bracket because of that bracket, parentheses because of the parentheses there. That's the interval notation. All right, so that's just a little bit of a review before we begin this section. Okay, now, here's the title of this section. The title of this section, we're going to look at equations. That means that they're going to have equal signs, and inequalities. That means it's a less than or a greater than or a less than or equal to or a greater than or equal to. But the key part is this: absolute value equations, absolute value inequalities. So what these problems are going to look like is you're going to have absolute value symbols in the problem. You're going to have an x in there because you're solving for x. And you're going to have an equal sign or an inequality symbol. So let me just give you a few visuals right quick. You don't have to write these down. This problem right here is an absolute value equation. This one is an absolute value inequality. This one is an absolute value inequality. So these are absolute value problems. Now, we did look at absolute value problem earlier in the course with something that was totally different, and that was graphing an absolute value function. That was where it was y equal. You had 2 letters in the problem. There's 2 letters is not in this problem. So this is something entirely different than what we did before when we were talking about graphing absolute value functions. So here's what we're looking at. We're looking at how do we solve absolute value equations and how do we solve absolute value inequalities. Now, if you take the absolute values off, I know how to solve this problem. But the whole dilemma is, how do I get rid of that absolute value symbol mathematically? If you'll remember in the last section, we covered radical equations, and your x was under the radical. And what did we have to do? You had to do something mathematical to get rid of that square root. And we did that. So what I've got to do in these problems is I've got to do something mathematical to get rid of these absolute value symbols. Now, how do I do that? Well, I'll show you that in just a minute. Okay. What I'm about to do is give you a note. Very important note here. So take down this note. Title the note, Steps in Solving. Steps in Solving Absolute Value Equations and Inequalities. Steps in solving absolute value equations and inequalities. So these steps is going to work every one of the absolute value problems. You just got to follow these steps, which means you have to know these steps in order to work the problems. Okay, here we go. Step 1. Isolate the absolute value term on one side and number on the other. Isolate the absolute value term on one side and number on the other. Okay, so in other words, when you finish step 1, you're going to have your absolute value symbol over here. You're going to have your symbol, your equal sign, or your less than, or greater than, or less than or equal to, or greater than or equal to. Then you're going to have a number over here. That's what step 1 says. Then get the absolute value by itself. Okay. Step 2. Identify A and B. Little a and little b. Identify little a and little b. I'll explain what that means in just a second. Step 3. Use one of the 3 formulas to rewrite the problem. Use one of the 3 formulas to rewrite the problem. All right, let me show you the 3 formulas here. All right, let's see. Okay, pause the video and write these 3 formulas down. Okay, I'm assuming you've written the formulas down, so let me talk about these just for a second. If you will notice, there's 3 different formulas here. This is formula 1, this is formula 2, this is formula 3. Now, the formula is actually this right here. Because if you'll read what step 3 says, it says, use the following formula to rewrite the problem. So what we're going to do is we're going to rewrite it this way. And again, I know right now this doesn't make any sense, but it will. So here's the formula part. Okay, and you say, well, what is this over here? Well, let's talk about the little a and the little b first. When I ask you what is little a is whatever is inside the absolute value. For instance, go back to these 3 up here. In this problem right here, If I ask you what is A, it would be 3x minus 2. In this problem, what is A? 7x minus 3. In this problem right here, what is A? 4x plus 1. So A is everything that is inside the absolute value. Now, what is B? B is what's over on the other side. But remember, we're in step 3. What did step 1 say do? Step 1 said isolate the absolute value term. So the B that's over on the other side is only the B if you've done step 1. Let me show you what I mean. In this problem right here, this is A, this is B. In this problem right here, this is A. In this problem, this is not B. So B is not 10 because you have to do step 1 first. Step 1 says get the absolute value by itself. So you have to subtract that 5 across. So 10 minus 5 is 5. So in this problem, B is not 10, it's 5. Same thing here. In this problem right here, A is 4x plus 1. What is B? B is what's over here after you get this by itself. So you'd have to add 3 to both sides. So 9 plus 3. So in this problem, A would be this. B would be 12. So that's how you identify A and B. Then, whatever A and B are, you're going to put them right here. Now, the next dilemma. So that's how you decide what A and B is, what A and B are. Now, the next question is this. How do you know which of these 3 formulas to use? And here's the answer to that. If the problem is an absolute value equal, if the symbol has an equal, you are always using this formula right here. Okay, now, if the absolute value problem has a less than or equal, you're always using this formula. Now, if it has a greater than or equal, you're using this formula right here. Now you say, well, Mr. Ryan, I got a question. What if it's not a greater than or equal in the problem? What if it's just a greater than? You're still using this same formula. Let me slide this up a little bit. So if it's an equal, we're using this. If it's a greater than or equal, we're using this. If it's a less than or equal, we're using this. That's how you decide which formula to use. Now, if it's a greater than and there's no equal to, you still use this formula, you just take off the equal to's. If it's a less than and not a less than or equal, if it's just a less than, we're still using this formula, you just take off the equal to's. So what is A? A is what's inside the absolute value. What is B? It's the number that's over on the other side after you've isolated the absolute value. How do we decide which formula to use? If it's absolute value equal, we're using this formula. If it's absolute value greater than or equal, we're using this formula. If it's just a greater than, we're using this formula. If it's less than or equal, we're using this formula. If it's just less than, we're still using this formula. So this is really not 3 formulas, it's 5. This is 1 formula, this is 2 formulas, and this is 2 formulas. All right, so that's when you plug in your A's, B's, and C's, or A's and B's, I'm sorry. Okay, now the 4th step. Solve the rewritten part and if the problem is an inequality, that means if you're using the 2nd or the 3rd formula, if the problem is an inequality, graph the solution on a number line graph the solution on a number line, and write the answer in interval notation. Okay, so this concludes this part of the video. So we'll stop here, and in the next video, we're going to actually start with the examples. But you'll need to keep this note handy for us to use the problems, use the formulas.